This is a mock interview on various tricky level questions on various subjects, including data structures and algorithm, design patterns, core Java concepts, Spring Boot and microservices, Hibernate, JPA, UML design, on these areas specifically. Okay, let's start. First, let's go along with the data structures and algorithm, then the design patterns and so on. Yeah, the first question is on the data structures and algorithm. How do you implement a LRU cache, which is least recently used cache in Java? And also explain the data structures you would use.
We'll give the answer this way. We can give it to implement an LRU cache in Java. I would use a combination of a doubly linked list and a hash map. The hash map allows order of 1, which is O of 1, access to cache entries, and the doubly linked list maintains the order of access, right? So the head of the list would point to the most recently used item, and the tail would point to the least recently used item. When an item is accessed, it is moved to the head of the list, and if the cache reaches its capacity, the item at the tail is removed. This ensures that the least recently used item is always removed first, right? So that's the main concept. Okay, yeah, I think that's pretty much from my side.
Okay, so given your implementation of the LRU cache, how do you handle concurrency issues?
The answer on this is like to handle concurrency issues in an LRU cache, you can use several strategies like synchronized blocks that synchronize the critical sections of the code that modify the cache, such as put and get operations, to ensure that only one thread can access these sections at a time. Second is concurrent collections. Use Java's concurrent hash map, which is a concurrent collection for the underlying storage, which provides thread step access and modification concurrently. For maintaining the order of the LRU cache, you can use a concurrent linked dequeue in combination with concurrent hash map. Third is read write locks. Implement read write locks using reentrant read write lock. This allows multiple threads to read the cache concurrently but ensures exclusive access for writes. Another can be like on atomic operations. Use atomic operations for critical modifications to ensure thread safety without full synchronization. For example, you can use atomic reference for atomic integer for counters or references that need to be updated atomically. Okay, I think that's pretty much we can handle concurrency on the LRU cache.
Cool. Okay, next question I can do for you, like given a binary tree, can you tell me the function to find the maximum depth?
Yes, to find the maximum depth of a binary tree, you need to traverse that tree and keep track of the depth. This can be done using a recursive approach, where you explore both the left and right subtrees of each node and then take the maximum of the two depths. You add one of the you can add one to the maximum depth to account of the current node. If a node is null, it contributes 0 to the depth. This ensures that the function returns the length of the longest path from the root to the leaf.
Nice, yeah. Okay, let's go to the next question. How do you detect a cycle in a linked list?
Yep. Detecting a cycle in a linked list can be efficiently done using Floyd's cycle finding algorithm, also known as the tortoise and hare algorithm. In this approach, two pointers are used: a slow pointer that moves one step at a time and a fast pointer that moves two steps at a time. If there is no cycle, the first pointer will reach the end of the list. However, if there is a cycle, the first pointer will eventually meet the slow pointer within the cycle. This method is efficient and only requires order of one extra space.
Cool. Yep. Okay, let's go to the next question. Can you explain the difference between a binary search tree and a B tree?
Yeah, sure. A binary search tree, BST what we call it, is a tree where each node has at most two children and the left child's value is less than the parent's value while the right child's value is greater. This structure allows for efficient searching, insertion and deletion operations, typically in order of log n time, provided the tree is balanced. And a B tree, on the other hand, is a self-balancing tree data structure that maintains sorted data and allows searches, sequential access, insertions and deletions in logarithmic time. Unlike a BST, a B tree can have more than two children. It is optimized for systems that read and write large blocks of data, such as databases and file systems, by minimizing the number of disk accesses. A B tree keeps its keys in sorted order and ensures that all leaf nodes are at the same level.
Cool. Okay, what are the advantages and disadvantages of using a heap data structure for implementing a priority queue?
Okay, got it. So advantages I can say on the heap data structure for implementing priority queue, like efficient access. Heaps allow order of one access to the highest priority element, always priority element. Then second is efficient operations. Both insertion and deletion operations can be performed in order of log n time, making heaps suitable for implementing priority queues. And yeah, and disadvantages I can say, not suitable for all priority updates. It prioritize need to be frequently updated. It also, I mean, it's if priorities needs to be frequently updated, heaps can become inefficient, right? I mean, should not be frequently that job, as they don't support efficient decrease key or increase key operations. And I think space overhead also. Heaps require additional space to maintain the heap structure, which can be a disadvantage in memory constrained environments. Yeah, yeah, I think that's all about the advantages and disadvantages of heap data structure on priority queue.
Okay, cool. Um, how do you reverse a linked list iteratively and recursively?
Okay, I think iteratively we can do this way, that to reverse the linked list iteratively, you would maintain three pointers: previous, current and next. You initialize previous to null and current to the head of the list. As you traverse the list, you update the next pointer to the next node in the list. Set the current nodes next to the previous node and then move the previous and current pointers one step forward. This process continues until you reach the end of the list, and the previous pointer will point to the new head of the reversed list. And recursively, to reverse a linked list recursively, you would use a base case where if the list is empty or has only one node, you return that node. For other cases, you reverse the rest of the list and then set the next node's next pointer to the current node. Effectively reversing the link, finally you set the current node's next pointer to null and complete the reversal.
Okay, cool. Can you explain how you would find the shortest path in a graph using Dijkstra's algorithm?
Okay, yeah, Dijkstra's algorithm finds the shortest path from a source node to all other nodes in a weighted graph. The algorithm maintains a set of visited nodes whose shortest distance from the source is known. It uses a priority queue to explore nodes with the shortest known distance from the source. The steps are as follows, like initialize the distance of the source node to 0 and all other nodes to infinity. Insert the source node into the priority queue. While the queue is not empty, extract the node with the smallest distance. For each neighborhood node or neighboring node, calculate the distance from the source to the neighbor through the current node. If the calculated distance is less than the known distance, update the distance and insert the neighbor into the priority queue. Repeat until all the nodes are processed in the same sequence or in the same steps.
Okay. So, in your explanation of Dijkstra's algorithm, how would you handle graphs with negative weights?
Okay, Dijkstra's algorithm is not suitable for graphs with negative weights because it assumes that once a node is visited with the shortest path, it will not be revisited with a shorter path later. For graphs with negative weights, you should use the Bellman-Ford algorithm instead, Dijkstra's algorithm. So this, I mean, Bellman-Ford algorithm way you can handle it. So this Bellman-Ford can handle negative weights and also detect negative weight cycle in the graph. It works by iterating over all edges and relaxing them, ensuring that even with negative weights, the shortest path is found.
Nice. Okay. So on my data structure and algorithm, I have another question like given an array of integers, can you tell me a function to find the longest increasing subsequence?
Okay, to find the longest increasing subsequence, what we call LIS, in an array, you can use dynamic programming, which is DP. The idea is to maintain an array where each element at index I represents the length of the longest increasing subsequence ending at index I. You initialize all values to 1 because the minimum length of any increasing subsequence is 1. Then for each element in the array, you compare it with all previous elements. If an element is greater than a previous element, you update the current element's value to the maximum of its current value or the value of the previous element plus 1. So 1, then 2. So just that way it will be increasing order, right? So finally, the length of the longest increasing subsequence is the maximum value in this array. This approach ensures that you consider all possible subsequences and their lengths efficiently.
Cool. Okay, now let's go ahead with the design patterns. Can you explain the singleton pattern and provide a thread-safe way of implementation in Java?
Yeah, sure. The singleton pattern ensures that a class has only one instance and provides a global point of access to that instance. It is useful in cases where exactly one object is needed to coordinate actions across the systems. And regarding the thread safe implementation, a thread safe implementation of the singleton pattern in Java can be achieved using various methods such as double check locking, the synchronized with the synchronized keyword, right? Like of course synchronize is required in the single checked also, but in double check twice we use it, or using the Bilpug singleton design as well. The idea is to ensure that only one instance is created even when multiple threads try to access the singleton instance simultaneously. So this can be achieved by using a private constructor and a static method that returns the instance.
Nice. Okay, can you describe the observer pattern and can give just yeah, observer pattern and how to use it?
Cool. Observer pattern is a, I can say, I mean, that is a behavioral design pattern that allows an object called the subject. I mean, that allows an object then called the subject and to notify a list of dependent objects called observers. Yep. of any state changes usually by calling one of their methods, right? So this pattern is often used to scenarios where an object needs to notify other objects without knowing who they are or how many they are. Like example, I'll say a very common example of the observer is publish subscribe system. Imagine a news agency, which is we call as subject, right? That publishes news articles, and subscribers or observers cannot subscribe to receive updates. Whenever the news agency publishes a news article, all subscribers are notified and receive the news article. This pattern is also widely used in GUI frameworks where the change in one component needs to update others, like a spreadsheet application where editing a cell updates corresponding charts, right? So those all the charts will be updated accordingly on those corresponding cell updates, right?
Okay, right. Okay, next question is like, what is factory design pattern and how is it different from the abstract factory pattern?
Yep. The factory pattern is a creational design pattern that provides an interface for creating objects in a superclass, but allows subclasses to alter the type of objects that will be created. It promotes loose coupling by eliminating the need to bind application specific classes into the code. And difference from abstract factory pattern, while the factory pattern deals with the creation of a single object, the abstract factory pattern is concerned with the creation of families of related or independent, or sorry, not independent, related or dependent objects. The abstract factory pattern provides an interface for creating a suite of related objects without specifying their concrete classes. It is typically used when there are multiple types of products to be created that need to be used together, ensuring that the products created are compatible with each other. So that's where this two things, factory and design, abstract factory, comes through.
Okay. Um, Next is like, how does the decorator pattern work? Can you provide a real world example on this?
Yeah, sure. The decorator pattern is a structural design pattern that allows behavior to be added to individual objects, either statically or dynamically, without affecting the behavior of other objects from the same class. It is useful for adhering to the single responsibility principle, as it allows functionality to be divided between classes with unique areas of concern. And real world example on this is a real world example of the decorator pattern is a very simple example, like a coffee shop menu. You start with a basic coffee, the component is called like just a coffee you have given, and then you can add various condiments like milk, sugar, cream. These are called decorators, right? So decorating elements we are putting into the coffee. Each decorator adds new functionality to the coffee, such as additional cost, description, etc. The original original object, right, which is coffee, remained unaltered, and each new decorated object maintains the same interface, ensuring that they can be used interchangeably.
Cool. Based on your example of the decorator pattern, how would you extend it to support multiple decorators?
To support multiple decorators in the decorator pattern, you can chain them together. Each decorator wraps the original object or other decorator, allowing you to stack multiple behaviors dynamically. For instance, if you have a base component and multiple decorators like decorator A, decorator B, and etc., you can wrap the base component first with decorator A and then wrap this result with decorator B, and so on. This way, when a method is called, it passes through all decorators in the chain, each adding its behavior.
Cool. Next question is, explain the concept of dependency injection and how it relates to the inversion of control pattern.
Okay, the answer on this is dependency injection, what we call DI, is a design pattern used to implement inversion of control, IOC we call it, where the control of object creation and binding is shifted from the program itself to an external framework. DI involves passing or injecting the required dependencies into a class out of the box, rather than the class creating the dependencies itself. This allows for better modularity and easier testing, as the dependencies can be swapped out easily. That's why mainly, right? And relation to inversion of control is like inversion of control is a broader principle where the flow of control is inverted compared to traditional procedural programming. Instead of the application calling the framework calls into the application code at specific points. DI is one of the ways to achieve IOC by injecting dependencies into classes, making the classes more flexible, easier to manage. For example, in Spring Framework, DI allows objects to be injected into other objects via constructor injection, stator injection, field injection, right? Ensuring that the objects are loosely coupled.
Now let's go ahead with the core Java concepts. We'll have some questions from here. So first question is, what are the differences between an abstract class and an interface in Java 8?
Yep. So in Java 8, both abstract classes and interfaces can have default methods, but they serve different purposes and have some key differences. I'll talk about those difference. So like in abstract class, we can say an abstract class can have instance variables, of course constructors also we have, and fully implemented methods also we can have. It can also define abstract methods that subclasses must implement, like whichever class extends the abstract class, there we must implement those abstract methods. And abstract classes are suitable for a base class where you want to provide default behavior and share code among closely related classes. So we can have both abstract methods as well as concrete methods inside abstract classes. And in interface, an interface in Java 8 can have default methods now and static methods as well. Earlier it was not there, this default and static methods were not supported by interface. From Java 8 onwards we have the default and static methods, but cannot have instance variables or constructors. It is primarily used to define a contract that multiple classes can implement, ensuring they provide specific behavior. Interfaces are ideal for defining capabilities that can be shared across unrelated classes. So these are the main differences, and in inheritance we can say that a class can extend only an abstract class but can implement multiple interfaces, right? So that is another difference, right? So interfaces can be implemented multiple, I mean a class can implement multiple interfaces, but extension of a abstract class we can do only from one class. So which allows for greater flexibility in design as well on this perspectives, if you can say, right?
Okay, cool. Can you share a real-time example you used in your code on this abstract class and interface? What you talked about Java 8?
Yep, in a real world scenario, let's consider an application for managing different types of payment methods in an e-commerce platform. We will use an abstract class and an interface to demonstrate this usage. So I'll tell the use case or scenarios. We have different types of payment methods like credit card, PayPal, and bank transfer. Each payment method needs to have common properties and behaviors like payment processing and etc. Additionally, each payment method may have some specific behaviors that are unique to that payment method. Like in we can create an abstract class which is called payment. So an abstract class is useful, right, here, because to provide common functionality and properties that can be shared among all payment methods, like a easy feature, right? So So here, like payment, we can create an abstract class, and there we can write different methods like validate payment and process payment, etc., right? And we can have interface as refundable, like which kind of payment methods are refundable, right? So an interface is useful here to define behaviors that can be optionally implemented by some classes, which is not required always, which is optionally implemented by some classes. Here we'll use an interface to define the refund behavior. Okay, so we can have a refund method inside the refundable interface, and we have another is abstract class which is called payment, right? So now we can create some concrete classes like credit card payment, then PayPal payment, bank transfer payment. These are my concrete classes. Now credit card payment, we can have of course the payment related also as well as refundable also, right? So we can do extends payment as well as implements refundable, and we can override those methods, and we can create our own implementation. Now PayPal payment, that is also possible with extension and refundable as well. So both will do extension as well as implements, right? And now bank transfer payment, right? So for bank transfer there is no refundable way. Now we can do only extends payment here, right? So that process payment and all will be involved, right? So only bank transfer payment extends payment. There is no implements refundable as it does not support refund. So that way we can create this payment application, right? So this is a real-time example on this. So here you can see, right, abstract class payment here provides common properties like amount, currency, methods like validate payment, process payment for all payment methods. The process payment method is abstract, forcing subclasses to implement their specific payment processing logic. And the interface what we can write refundable, so it defines the refund method. This interface is implemented by credit card payment and PayPal payment, but not by bank transfer payment, as it does not support, right? So that demonstrates optional behavior here. And these concrete classes what we have written, so each concrete class extends the abstract class and optionally implements the interface to provide some specific functionalities. So this design allows for flexibility and reuse of common code while enabling specific behaviors for different types of payments.
Yeah, nice. So we'll go to the next question. Can you explain the concept of Java memory model and the significance of the volatile keyword?
Yeah, sure. So the Java memory model, what we call JMM, defines how threads interact through memory and what behaviors are allowed in a multi-threaded environment. It ensures visibility of changes to variables across threads and defines rules for reads and writes to variables to prevent unexpected results. Here the volatile keyword in Java ensures that the value of a variable is always read from and written to the main memory rather than being cached by the thread. This guarantees visibility of changes to variables across threads. For instance, if one thread updates a volatile variable, the new value is immediately visible to all other threads that read the variable. However, volatile does not guarantee atomicity, so operations like incrementing a variable are not thread safe even if the variable is declared volatile. Yep.
Cool. So following your explanation of the Java memory model, um, how would you avoid deadlocks in a multi-threaded environment?
Okay, so avoiding deadlocks in a multi-threaded environment involves several strategies. Lock ordering one, right? So like always acquire locks in a consistent predefined order. This prevents circular wait conditions, which are a primary cause of deadlocks. What we can do through, of course, there are locking mechanisms as well as the I think you can do with synchronized as well, right? Timeouts, another is like use lock acquisition with timeouts, such as try lock with a timeout parameter. If a thread cannot acquire a lock within a specified time, it can back off or try a different approach. Then avoid nested locks, of course. Minimize the use of nested locks. If you must use nested locks, ensure that they are acquired and released in a consistent order. Then we can say deadlock detection, of course. Implement deadlock detection mechanisms that periodically check for circular weights and take corrective actions if a deadlock is detected. Then using higher level concurrency constructs, it utilizes higher level concurrency utilize from Java util concurrent package such as executor service, countdown latch, semaphore, cyclic barrier, which are designed to reduce the risk of deadlock. So use the already available classes and interfaces, right, which by default supports the reduce of risk of deadlocks.
Cool. The next question is, how does Java's garbage collector work? Explain the difference between CMS and G1 garbage collectors.
Java's garbage collector automatically, the GC automatically manages memory by identifying and discarding objects that are no longer needed by the application, thus freeing up memory resources. It primarily works in generations, managing the heap memory in regions such as the young generation, where most objects are initially allocated, and the old generation, where long lived objects are promoted. So whichever are short lived, they will not be there anywhere, right? So whichever are initially allocated, they will go to the young generation, and which are long lived objects, they will go to the old generation. Now the CMS, the concurrent mark sweep algorithm, right? So the CMS garbage collector aims to minimize pause times by performing most of its work concurrently with the application. It has two main phases: the marking phase, where it identifies which objects are reachable, and the sweeping phase, which in the sweeping phase, where it removes unreachable objects. So mark is marking those objects which are reachable, right? Identifies which objects are reachable, and sweeping phase is like it removes the unreachable objects, right? CMS can lead to fragmentation as it does not compact the heap. Okay, and G1, the garbage first algorithm, the G1 algorithm, the garbage collector, it is designed to provide predictable pause times and better manage large heaps. It divides the heap into regions and performs incremental garbage collection. G1 combines both marking and compacting to avoid fragmentation and uses a mixed collection mode to efficiently manage the memory regions, prioritizing regions with the most garbage. So when there are most garbage, they will be prioritized first. So those will be garbage collected first, right?
Okay, cool. Next question is, what are the new features introduced in Java 11?
Yep. So Java 11 released in September 2018 introduced several new features and enhancements, including local variable syntax for lambda parameters. You can now use the var keyword for lambda parameters, making the code more concise and improving readability. Then HTTP client API, another feature. A new standard HTTP client API was introduced to replace the old HTTP URL connection API, providing a more modern and efficient way to handle HTTP requests. Another feature is nest based access control. This feature improves the accessibility of nested classes and their members, allowing better encapsulation and security. Another feature on the string methods, several new methods were added to the string class such as isBlank, lines, strip, repeat, then strip indent, etc. Then another feature is removal of deprecated features. Several deprecated features and APIs were removed, including the Java EE and COBA modules. Another feature is flight recorder and machine control. These tools were open sourced and included in the JDK, providing powerful tools for profiling and monitoring Java applications.
Okay, nice. So next question is on okay, how would you handle exceptions in Java? Explain the difference between checked and unchecked exceptions.
Okay, in Java, exceptions are handled using try-catch block. You enclose code that might throw an exception within a try block and catch the exception in the catch block, where you can handle it appropriately. Optionally, a finally block can be used to execute code regardless of whether an exception was thrown or not. Typically for resource cleanup, now there is a try with resources option is also there, right? Checked exceptions, these are exceptions that that must be either caught or declared in the method signature using the throws keyword. They represent conditions that a reasonable application might want to recover from, such as IO exception or SQL exception. The compiler enforces handling of checked exceptions, ensuring robust error handling. And unchecked exceptions, these include runtime exceptions that and its subclasses such as null pointer exception or array index out of bounds exception. They represent programming errors or conditions that the application usually cannot recover from. Unchecked exceptions do not need to be declared in the method signature or caught, allowing for cleaner code but placing the responsibility on the developer to ensure proper handling and avoid such errors. So you have to fix in the code properly for the unchecked exceptions or runtime exceptions.
Okay, after describing your exception handling strategy in Java, how would you log and monitor these exceptions in a Spring Boot application?
Yeah, to log and monitor exceptions in a Spring Boot application, you can use the following approach. Logging framework, of course, use a logging framework like SLF4j with logback or log4j. Configure the logger in your application.properties or application.yaml file to specify the logging labels and appenders. Then global exception handling, implement a global exception handler using controller advice or and exception handler annotations. This allows you to handle exceptions across the whole application and log them appropriately. Then custom error responses, customize error responses for different types of exceptions by returning meaningful message and HTTP status codes from the global exception handler. Then monitoring tools, integrate monitoring tools like Spring Boot Actuator, which provides endpoints to monitor application metrics and health. Use tools like ELK Stack. ELK is nothing but Elasticsearch, Logstash, Kibana, or Prometheus and Grafana to aggregate, visualize, and analyze logs and metrics. Then of course centralized logging, use a centralized logging solution where logs from different services are collected and stored in a central location, making it easier to search and analyze them. So this is mainly required for different microservices collecting in a single centralized logging system.
Okay, okay. So next question is on this, what are the rules you need to follow to write custom immutable class in Java?
Yep. So to write a custom immutable class in Java, you need to follow certain rules to ensure that the object state cannot be changed once it is created. Right. Here are the some rules you need to follow. Like first is like declare the class as final, of course. Right. So by declaring the class as final, you prevent other classes from subclassing it, which could potentially break the immutability. Right. Second is make all fields private and final. So all fields should be declared private and final. This ensures that they are only initiated once and cannot be modified afterwards. Third is initialize all fields in the constructor. All fields should be initialized in the constructor. Avoid creating setter methods or any other ways to modify the fields after the object is created. Fourth is perform deep copy for mutable fields. So if your class has fields that are mutable objects like different collections, right? You can add or delete, right? You can do those things. So for those mutable objects, ensure that you perform a deep copy of these objects during initialization and when returning them in getter methods, right? In both places. Fifth, avoid exposing mutable fields. Do not provide methods that expose mutable fields or allow them to be modified. Instead, return a copy of the mutable field. Don't return the same fields, just copy that into a different temporary variable and return that. Then sixth is ensure thread safety. Although immutability inherently provides thread safety, make sure that any methods you add do not compromise this. Avoid synchronization issues by not allowing any changes to the state after construction. So you have to ensure the thread safety because immutable concept is on the thread safety, right? And seventh, provide methods for controlled modification. So if you need to provide methods to change the state, ensure they return a new instance of the class with the modified state instead of modifying the same current instance. So whenever you're creating the you're trying to create the object, right, it should return a new instance always. Okay, you should not modify the same object what you have created earlier, right?
Awesome. So now let's go towards the Spring Boot and microservices. Can you tell what is the Spring Boot and how does it differ from the traditional Spring framework?
Yeah. So Spring Boot is an extension of the Spring framework that aims to simplify the setup and development of new Spring applications. It provides a range of non-functional features common in large-scale projects, such as embedded servers, security, metrics, health checks, and externalized configuration. The key differences between Spring Boot and the traditional Spring framework includes like auto configuration, embedded servers, right? Starter dependencies, optional, opinionated defaults, then production ready features. These are different features, right? Out of the box, we get it. So like auto configuration, right? Spring Boot automatically configures your application based on the dependencies you have added, reducing the need for manual setup and configuration. So it will be taken care automatically. Then embedded servers, Spring Boot can run applications using embedded servers like Tomcat, Jetty, Undertow, right? Eliminating the need for deploying WAR files to external servers like earlier days we used to do that, right? Now it's not required with Spring Boot. Then starter dependencies. It provides a set of starter dependencies that simplify dependency management by providing a convenient set of transitive dependencies, right? Then opinionated defaults, like Spring Boot offers opinionated defaults that make it easier to get started with Spring application by providing sensible default configurations and reducing boilerplate code. Then production ready features. Spring Boot includes various production ready features such as monitoring, health checkups or health checks, and externalized configuration, making it easier to deploy and manage applications in production, right? This is a production ready features altogether.
Our next question is explain how you would secure a Spring Boot application. So the Spring security mainly, right?
Yeah, the securing a Spring Boot application can be achieved through several approaches. Spring Security, utilizing Spring Security to manage authentication and authorization. It integrates seamlessly with Spring Boot and provides comprehensive security features such as securing endpoints, managing user roles, and handling login and logout functionalities. Second is HTTPS. Configure your application to use HTTPS to ensure encrypted communication between the client and the server. This involves setting up an SSL certificate and configuring your embedded server to use it. Third is OAuth 2 and JWT. For more robust security, implement OAuth 2 for token based authentication. Use JWT, which is JSON Web Tokens, to ensure stateless authentication, making it easy to scale your application. Then next is CSRF protection. Enable cross-site request forgery CSRF protection to prevent unauthorized commands from being transmitted from a user that the web application trusts. Next is role-based access control, what we call RBAC. Define user roles and permissions to restrict access to certain parts of your application based on the user's role. Then security headers. Configure security headers such as content security policy CSP, X content type options, X frame options to prevent various types of attacks like XSS and click jacking, etc. Then input validation and sanitization. Ensure all user inputs are properly validated and sanitized to prevent injection attacks such as SQL injection or XSS.
Okay, so given your solution for securing a Spring Boot application, how would you implement JWT based authentication?
Okay, yeah, to implement JWT based authentication in a Spring Boot application, you can follow these steps. Dependencies first, like add the necessary dependencies for Spring Security and JWT in your pom.xml or build.gradle file. Then user authentication, implement a user authentication endpoint that validates user credentials and generates a JWT token upon successful authentication. Next, JWT token generation. Use a JWT library like JWT, right, to create and sign the JWT token. Include user information and claims in the token payload. JWT filter, like create a JWT filter that intercepts incoming requests, extracts the token from the authorization header and validates it. If the token is valid, set the authentication context. Next is security configuration. Update the Spring security configuration to use the JWT filter instead of the default form based authentication. Configure security rules to protect specific endpoints. Next, token based, like token expiry and refresh. Implement token expiry handling and provide an endpoint to refresh tokens, ensuring that users remain authenticated without having to log in repeatedly.
Cool. Next question is how would you implement service discovery in a microservices architecture?
Okay, service discovery in a microservices architecture can be implemented using tools like Eureka, Console, or Zookeeper. Here's how you can implement it using Spring Cloud, Netflix, Eureka. Like in Eureka server, set up the Eureka server, which acts as a registry for microservices. All microservices will register themselves with the Eureka server upon the startup. Then we have to take the Eureka clients, where configure each microservice to act as a Eureka client. This allows the microservices to register themselves with the Eureka server and also discover other services from the registry. We have to have the load balancing. Use Ribbon or Spring Cloud Load Balancer to distribute requests among instances of a service. This ensures high availability and resilience. Next is on the service communication. Use Feign or REST template to make inter-service calls. Feign integrates well with Eureka and Ribbon, simplifying the service-to-service communication by automatically using service discovery and load balancing. Next, we need to have health checks. Configure health checks to ensure that only healthy instances of a service are registered and discoverable.
Okay, so next question is what are some common issues faced when designing a microservices architecture and how would you address them?
Yeah, some common issues faced when designing a microservices architecture include service communication. Microservices need to communicate over the network, which can introduce latency and potential points of failure. Using resilient communication patterns such as circuit breakers, retries, and timeouts can mitigate these issues. Then data consistency. Maintaining data consistency across microservices can be challenging. Implementing eventual consistency and using patterns like Saga or CQRS. So CQRS is nothing but command query responsibility segregation. This can help manage distributed transactions. Next is monitoring and logging. With multiple microservices, centralized logging and monitoring become crucial. Using tools like ELK, Stack, or Prometheus or Grafana for monitoring and distributed tracing, tools like Zipkin or Zyger can provide insights into health and performance of the system. Next is service discovery. So dynamically discovering and managing services is essential. Implementing a robust service discovery mechanism such as Eureka, Consul, or Zookeeper ensures that services can locate each other efficiently. Next is on the deployment and orchestration. Managing deployments and orchestration of microservices can be complex. Using containerization or with Docker and orchestration tools like Kubernetes can streamline deployments, scaling, and management of microservices. Then on the security, ensuring secure communication between microservices and managing authentication and authorization can be challenging. Using OAuth 2, JWT, and secure communication protocols like HTTPS can help secure the system. And last but not least, on the inter-service dependencies between services can lead to tight coupling and cascading failures. Designing services to be as independent as possible and using resilience patterns can reduce this risk, right? Like solid principles we need to design. So yeah, these are the few common issues and resolution we can give them for the microservices.
Okay, cool. So next question is, can you explain how you would implement a circuit breaker in a microservice using Spring Cloud?
Yep, implementing a circuit breaker in a microservice using Spring Cloud can be done using Spring Cloud Netflix Hystrix or Spring Cloud Circuit Breaker. How we can do it with Hystrix here, I'll tell you. With Hystrix dependency, first we need to add the Spring Cloud Netflix Hystrix dependency in our project. Then we have to enable the Hystrix. So annotate your main application class with @enable Hystrix to enable Hystrix. Then circuit breaker configuration, use the @Hystrix command annotation or method that call external services configure fallback methods to be executed when the circuit breaker is open or when the call fails. Then dashboard and monitoring step, set up Hystrix dashboard and turbine. for real-time monitoring of the circuit breakers. This provides insights into the health and performance of the circuit breakers. Then Resilience 4J, with the deprecation of historics, you can also use Resilience 4J, a lightweight and easy to use library for implementing circuit breakers. It integrates well with Spring Boot and provides various resilience patterns like rate limiting, retries, and bulkheads. You can use the circuit breaker annotation to apply circuit breaker functionality to your methods and configure fallback mechanisms similarly. So implementing circuit breakers help um prevent cascading failures, improve system stability, and ensures graceful degradation that services fails or become unresponsive. Right there, it will be very useful.
Cool. Now let's go ahead with the Hibernate and JPA. So can you tell what are the key differences between Hibernate and JPA?
Yep, sure. So Hibernate and JPA are both used for object relational mapping in Java applications, but they have some key differences. So JPA, like what we call Java Persistence API. So JPA is a specification for accessing, persisting, and managing data between Java objects and a relational database. It defines a set of interfaces and annotations that ORM tools can implement. JPA is part of the Java EE and Java AC specifications and provides a standard way to perform ORM in Java. And Hibernate is a ORM tool and framework that implements the JPA specifications. So JPA is a specification and Hibernate implements the JPA specification. So Hibernate provides additional features and functionality beyond the JPA standard, such as more caching strategies, then advanced fetching strategies, and support for specific database features, right, etc. Then flexibility and features point of view, while JPA provides a standard set of ORM features, Hibernate offers more advanced features like custom data types, better caching support, and enhanced query capabilities through the Hibernate query language, right? On the usage perspective, JPA provides a common interface that can work with multiple ORM frameworks. Like it's not only on the Hibernate, right? So JPA specification can be implemented by others also, like Eclipse Link, OpenJPA, and all, making this application more flexible, right? You can change it according to your requirement. Hibernate as a specific implementation ties the application to Hibernate's API and features, but provides more powerful ORM capabilities.
Okay, so next question is, how does the Hibernate caching mechanism work? Explain the difference between first level and second level caching in the Hibernate.
Yep. So Hibernate's caching mechanism improves the performance of the application by reducing the number of database queries. There are two levels of caching in Hibernate: first level cache and second level cache. So first level cache is associated with the Hibernate session and is enabled by default. It stores entities that are loaded or saved within the session, making them available for the duration of the session. So how long session lives, that particular session, in that particular session the object lives. This cache is local to the session, meaning that if you load an entity within a session, Hibernate will retrieve it from the cache. If it's accessed again within the same session, avoiding additional database queries, it will pick it up, right? And second level cache is associated with the session factory and is shared across multiple sessions. It stores entities and collections at a higher level, making them available for reuse across different sessions. Second level cache needs to be explicitly enabled, which is not by default. It is not enabled, right? We have to explicitly enable it and configured with a caching provider like Cache or Infispan, right? It helps improves performance by reducing the number of database access for frequently accessed entities. especially in a clustered environment where multiple sessions may need the same data. So difference we got mostly. So the main difference is the scope and duration of the cache. First level cache is session specific and short lived, while second level cache is shared across sessions and can be long lived, providing a global cache for entities across the application.
So, on this, the question comes, in your explanation of Hibernate caching, how would you decide what data to cache at the second level?
Okay, deciding what data to cache at the second level in Hibernate involves considering several factors. First is read heavy data, right? So cache data that is frequently read by frequently but infrequently updated, right? So data frequently read but infrequently updated. Okay, those are required. So this ensures that the cache remains valid and reduces the load of the database. Then static or rarely changed data. Cache entities that do not change often, such as reference data, lookup tables, or configuration settings. Then expensive queries. Cache the results of queries that are expensive to compute or involve complex joins and calculations, reducing the need to to recompute them. Then data size, consider the data size of the data being cached. Avoid caching large data sets that can quickly exhaust the cache memory and lead to multiple users or sessions. Then consistency requirements, ensure that the data cached at the second level does not have strict consistency requirements. Use appropriate cache eviction and invalidation strategies to maintain data integrity.
Okay. Next questions comes, what are some strategies for optimizing performance in Hibernate?
Yep, so optimizing performance in Hibernate involves several strategies. Caching first, like use first level and second level caching to reduce database access. Configure and tune the second level cache properly with a suitable caching provider. Second is batch processing. Use batch processing to reduce the number of database round trips by grouping multiple inserts, updates, or deletes into a single batch operation. Third, fetching strategy. Use appropriate fetching strategy like lazy loading, eager loading, and fetch joins to minimize the number of SQL queries and avoid unnecessary data retrieval. And then another fourth is like query optimization. Optimize SQL or JPQL queries by using indexes, avoiding unnecessary joins, and selecting only the required fields. Use pagination to limit the number of results returned by queries. Fifth is on the connection pooling. Use connection pooling to manage database connections efficiently and reduce the overhead of opening and closing connections. Read-only transactions. Use read-only transactions for read-only operations to avoid unnecessary locking and improve performance. Then we have the entity design entities and relationships carefully to avoid excessive joins and large result sets. Use appropriate data types and avoid storing unnecessary data.
Okay, so next question is, explain the concept of lazy loading and how it is implemented in Hibernate.
Lazy loading is a design pattern used to defer the initialization of an object until it is actually needed, improving the application's performance and memory usage. Implementation in Hibernate, lazy loading is implemented by default for associations like collections, one to many to many, and can be enabled for single valued associations also, like many to one or one to one, using the lazy annotations. When an association is marked as lazy, Hibernate does not load the associated entities immediately when the parent entity is fetched from the database. Instead, it loads a proxy object that will be initialized only when a method on the associated entity is accessed. Example, Suppose you have an entity order with a list of order item. If lazy loading is enabled, when you fetch an order from the database, the order item entities are not loaded immediately. They are only fetched when you explicitly access the order item list, such as calling like here order.get order items. So then only it loads the data from the database. This can significantly improve performance, especially when dealing with the large collections or deeply nested associations, by avoiding unnecessary database queries and reducing the amount of data transferred.
Cool. So next question, we'll do some designing perspective. So how would you represent a one-to-many relationship in a UML class diagram?
In a UML class diagram, a one-to-many relationship is represented using a line like connecting two classes, with a 1 near the class that represents the 1, and a star near the class that represents the many, right? Many site. So for example, if you have a customer class and an order class, so and each customer can have multiple orders, so you would draw a line from customer to order. The line would have a 1 near customer and a star near order, indicating that one customer can have multiple orders. So wherever 1 is mentioned, there will be numeric 1, and where many will be there, there will be star, right? So that's how we follow. So you can also add an arrowhead to the line if the relationship is navigable in a specific direction. Additionally, you may include annotations or labels to specify the role names or multiplicity constraints for further clarity.
Okay, so following your UML class diagram representation of a one-to-many relationship, how would you handle inheritance and polymorphism in the diagram?
Yeah, in a UML class diagram, handling inheritance and polymorphism involves using generalization and association. So generalization is like use a solid line with a hollow triangle pointing to the superclass to represent inheritance. So this shows that one class inherits from another class, right? So subclass is inheriting from superclass. For example, if you have a superclass vehicle and subclasses like car and truck, you would draw lines from car and truck to vehicle with a hollow triangle at the vehicle end. So hollow triangle should be at the vehicle end because we are extending from vehicle side, so the triangle should be hollow triangle should be at the vehicle side. So that's called generalization. Now polymorphism indicate polymorphic behavior by showing that a single interface or abstract class can be implemented or extended by multiple classes. For instance, if vehicle is an abstract class or interface, you can show that car and truck implement or extends vehicle, right? So that way you can do the polymorphism. So association with association with inheritance. How? When representing associations between classes and involve inheritance, you can connect the associations to the superclass. For example, if a garage has many vehicles, draw a one-to-many association line from garage to vehicle, even though vehicle is a superclass of car and truck. Okay, because garage has many vehicles, right? So you can do that one-to-many associations. Then role names and multiplicity include it includes role names and multiplicity at the ends of the association line to indicate the nature of the relationship. This helps clarify how many instances of each class participate in the relationship and their roles. By using these techniques, you can clearly represent inheritance and polymorphism in your UML class diagrams, providing a comprehensive view of the system's architecture and behavior.
Okay, next question come on the describe how you would use a sequence diagram to model the interaction between objects in a software system.
Yeah, so a sequence diagram models that the interaction between objects over time in a software system, showing how objects communicate with each other to accomplish a specific task. It consists of the following elements. One is lifelines, represent objects or actors involved in the interaction. Each lifeline is depicted as a vertical dashed line starting with a rectangle containing the object or actor name. Then messages represent communication between lifelines. Messages are shown as a horizontal arrows from the sender to the receiver, labeled with the message name or method call. Then we have the activation bars, represent the period during which an object is performing an action or is active. They are shown as thin rectangles along the lifeline. Then we have the loop fragments, alt, opt, or loop fragments, like represent conditional logic. They are optional interactions or repeated interactions. These fragments are depicted as rectangles enclosing part of the diagrams, labeled with the appropriate keyword. So to create a sequence diagram, we should do like identify the objects and actors involved in the interaction and draw their lifelines. Then determine the sequence of messages exchanged between the objects starting with the initial message. Draw the messages as arrows, labeling them with the method call or message name. Then add activation bars to indicate when an object is active or processing a message. Then use alt or opt or loop fragments if there are conditional branches, optional interaction or loops. So like for example, in a logging system, you would show the interaction between the user to login page, the authentication service and the database. The diagram would illustrate like you have to do those things in the sequence method calls for entering credentials, validating them and returning the result to the user, right, from top to bottom, right, from start to end.
Okay, so here is the last question comes. What is the purpose of a use case diagram and how would you create one for a login system?
Okay, a use case diagram represents the functional requirements of a system, showing the interactions between actors, users or external systems, and the system itself. It helps to visualize the different ways users can interact with the system and understand the system's functionality from a user's perspective. So to create a use case diagram for a login system, right, what do we do? So first identify actors, determine the actors involved in the login process. For a login system, the primary actor is usually the user. Then identify use cases, identify the use cases that represent the interactions the actor has with the system. For a login system, typically use cases include enter credentials, authenticate user, display login result, and handle login failure, etc., right? Then we have draw actors, draw stick figures to represent the actors and place them outside the system boundary. Then draw use cases, draw ovals to use to represent use cases and place them inside the system boundary. Then connect actors and use cases, draw lines connecting actors to the use cases they interact with. For example, draw a line from the user actor to the enter credentials use case and another line from the user to the display login result use case, and so on. Then add relationship if anything is there. Use include or extend relationship to represent common functionality or optional behavior between use cases. For instance, the authenticate user use case might include the validate credentials use case as well, right? So that's one kind of relationship here. So a use case diagram for a login system provides a clear overview of the login process, highlighting the main interactions and functionality involved, and serves as a valuable tool for communication between stakeholders and developers.
So for the mocking interview, these are the very top level 40 tricky interview questions. So that's all from our side. Thank you so much